Guys, I am so amped for this project. Though it's currently giving me a little bit of trouble. The charge is a little bit more than I expected. And now the pressure is mounting. Seriously, the way this is going, it's shocking. Sorry, I know I just keep going around in circles with this. This is just so exhausting. I just have no energy left. I know all of these jokes are fitting, but it's just tough to get pushed in the right direction. Once I find a creative outlet, I'm golden. Just gotta make the right connection. I feel so drained, but I am so pumped for this. There's just something about it I can't resist. Say what?
Living my life the way that I wanna, so is it hell, or is it I
Hi everyone, I'm Kayla from McNerdy Costumes Props, and welcome back to part 2 of the Excalibur build series. I am having so much fun with this process, and I cannot wait to share it with you. Please excuse my appearance for the next couple of videos because all of the work is being done here in my garage, and the heat wave is making things increasingly difficult. Now we're moving on to part 2 of this build, which involves the mechanical and electrical components inside the stone. Part 1 was the process of making the sword, and if you're curious, I've linked a video down in the description below. I've also decided that since this project is so time-consuming, I wanted to make another video that basically just works as a summary for the entire project. It'll have the whole process, just much less in-depth. It kind of works as a recap to just let you know everything that's gone on from start to finish. That way, if you don't want to watch the whole video series and you just want an overview of the finished product, that'll get released sometime next month. So, let's get started on the inside of the stone.
So the first thing I need to do is put together a box that houses all of the mechanical components that make the sword clamp work. The box is pretty simple, just some 2x4s and 4x4s. And here's the box all put together with a structural board in the middle to help it hold its shape on the bottom. The top, however, did not hold its shape. It tapered inward the nearer the top it got, but that's okay. I'm no master woodsman, and I'm going to sand these corners off anyway. It's alright if it's a little uneven. It is rock after all. So the next thing I decided to do was make the pieces that actually hold the sword into place. I decided to use these old chair cushions because the foam compresses, and if you think about it from a physics standpoint, a flat board wouldn't hold anything in place, but because the foam compresses around the sword, it gives it more gripping area and surface area for the sword to be held in place. I attached these old yoga mats to the foam to help give it a more sticky and grippy surface because the foam itself just wouldn't hold the sword into place. It would slide right out. I like this spray contact adhesive because you just spray it on one side of whatever you're trying to glue and spray it on the other, and when you attach them together, they stick really well and the glue is also very flexible. Once I cut off the extra pieces of the yoga mat, the glue is then applied to the back sides of the foam and onto the boards, and here are my very technical methods of applying and making sure that there's enough pressure to get them to hold still. So here I'm taking apart an old microwave so I can use the parts inside to make an electromagnet to hold the sword in place. Spoiler alert, as you'll see later on, I don't end up using it, so I won't be going into full detail about this process, but if it's something you're interested in seeing, let me know in the comments. Now we're wiring up the system to check and see if the magnet works, which it does, and wire in a switch to turn it on and off. I'm not experienced with wiring, so I enlisted a little bit of help with this part. Thanks, Josh. Then I made a box to stabilize the magnet. I ran long screws through to keep it from pulling itself off of the board and screwed it into the rigid beam at the bottom of the housing. Once that was attached, it was time to figure out how to attach the moving board to clamp the sword. Alright, so now here we've got this box attached to here, and then now we can put the other board on here with a hinge to have it swing. I'll be right back to show that shortly. Unfortunately, in testing, having the board clamping at the bottom left too much room at the top for the sword to slide out. I moved the hinge to the bottom and altered my design for 2 electromagnets at the top closer to the hilt. I also attached these old resistance bands to get a stickier grip on the inside and hopefully provide a little more friction. The system opens and closes nicely. Now it's just time to figure out how to attach the metal plates to the other board. I removed the boards from the top and then clamped the sword into place to hold it still while we attached the board with the metal plates. Then on a separate board, we countersunk some screws into some scrap metal to have the flattest gripping surface possible for the magnet. Looks like the metal plates line up with the magnet. Now it's time for the moment of truth. Remove the clamps and see if it holds the sword in. Success! The sword is seriously difficult to remove. I started to think about different positioning of the magnets and maybe some painted on silicone on the gripping surface to hold it down better when I noticed a funny smell. Yep, that's right, the magnet is getting so hot it's smoking. The magnet didn't work for two reasons. One, because the hotter it got, the less it worked, and also because it was too hot for the system, so I decided to use these pneumatic compression pistons instead. So I modified the system to pull the movable board towards the immovable one to hold the sword that way. The ends of the pistons are attached to the board by this metal rod that holds them in place and keeps them from slipping off. Hopefully, when the compressor is hooked up, this will clamp the sword in with enough force to keep it from being pulled out. I am way out of my element and realm of expertise in this part of the project, so I'd like to give a big huge shout out to Nathan and Stefan for their invaluable help in helping me understand the pneumatics and the way the system works. After hooking up the hoses and the electrical components, it's now time to test the system to see if it really works. At this point in the project, I started to get really frustrated. It seemed like nothing was going right. The system kept leaking and wasn't properly working. At the time, I didn't understand enough about the pneumatics to troubleshoot myself. I also really missed the idea of using the electromagnets. I wanted every part of this project to be as recycled as possible. I felt like I was cheating by just ordering parts offline instead of trying to make them out of recycled materials, but that would have been a project in and of itself in which, again, I have no realm of expertise. Though I felt like I was betraying my ideals, it would do nobody any good to be unsafe about this and set the system on fire, though I didn't already want to do that myself at this moment. The moral of the story is, don't be afraid to ask for help if you need it, so I decided to use a lifeline and phone a friend. Stefan's got great experience working with electronics, and he was able to help me understand what I was doing wrong. The system worked just fine hooked up to the compressor, but I couldn't get the electronics to work with me properly to get it to release. It turns out the wire that I'd salvaged from an old motor was too thick to be able to make proper contact with the solenoid. I also used some thread tape and some new fittings to solve the leaking problem I was having with the hoses. After some thinner wire was installed, even though the system says a 9-volt is enough, it just won't be enough power, so we used a car battery instead. Finally, after 2 full days of struggling with this project, we finally had a glimmer of hope. Finally, the system was working properly, and the only problem I had left to solve was to change how quickly the system was releasing the sword because I didn't want it to be immediately evident to anybody on the outside that it was going to come out.
I'm not the true king!
Nope, not coming out. Okay, so I know this looks a lot different from the last time I was showing the box. However, there was a lot of finagling and a lot of work that went into trying to figure out how to make this system work. So now I'm just going to show you where the progress is sitting. So the first thing we did was add these boards here against this back one to help support the pistons right here, which we attached with the strapping. And then we put a rod through this side of the box so that it will push on the sword. So we've got all of our lines all connected. These are the intake. And then this down here is the exhaust with the controller. And all of this is attached to the solenoid. So when we hook up the compressor, this is the system the way it's supposed to work. And I'll have my lovely assistant here today try and give that a tug. Yep, not coming out, which is exactly what we want. But when the sensor is tripped, yeah, that's exactly what we want. Woohoo! You're the one true king. Okay, so this is the progress so far, and the last thing that I need to do to get the system working properly is to hook up this box down here somewhere and then insulate it so that way the sound, when it pushes out, it doesn't indicate to anybody that they're going to be the winner. We don't want them to hear that. So next step is putting a little insulated box in here to house the solenoid. We installed the floor and put the system on metal casters because it was starting to get rather heavy. I also decided to opt out of the insulated box because plastic itself is a great insulator, so when I put the shell around the outside, I'm curious to see just how much sound is reduced. I also need some sort of mechanism that tells the pneumatics when to release the pressure. My idea was to use coins, and if you remember these from the prior video, they didn't turn out so well. The surface tension of molten aluminum is very high, and no matter what I did, I couldn't stop the molten aluminum from bubbling up over the top. The pouring trench failed, and even carefully pouring the aluminum one by one into the molds still resulted in a coin that was way too thick. Don't you ever tell Josh I said this, but he was right. I'd have to use a 2-part mold like I did for the sword to cast these. I started by putting a coin slot into this pretty decorative box to house the electronics. I'm using cardboard right now as the base, and then once everything's all lined up correctly, I can make everything out of wood. Everything looks great. I'll just have to shake the box once in a while to reposition the coins so they don't get clogged up in the mechanism. During this time of waiting, I also decided to cast another sword. I ended up sanding off all the little details on the handle and the hilt, and it turned out so much nicer with much less flashing than the other one. I also had a little problem with the sanding wheel being a little bit too aggressive for the runes on the blade, so I carved them out a little bit deeper on the master. Overall, the second cast was much nicer, but I had a little problem with the two halves not lining up properly. Somehow it must have gotten bumped during the casting process. I'll have to figure out some sort of pins or dowel rods to hold the two sword halves in place while they're being cast. So while I'm working on perfecting the coins, I also need to come up with some sort of mechanism that when I insert the coin, it tells the system to release the sword. So what I'm looking for is a 1 in 100 winner, so that when people come up and they purchase the coin to be able to put it through the system, I'm looking for 1 in 100 winners. So I need the system to count the coins as they come in, and if by 100 there is not a winner, then automatically number 100 is a winner. But I also need something like a demonstration. So I'm supposed to give a presentation for this project, and so I'd like to have 1 in 5 be a winner there. So I'm not experienced with wiring or electronics. I enlisted a little bit of help with this part of the project again. My stepdad has always helped me with all of my science fair projects, and why should this one be any different? Look who's here to help!
All right, let's give a demo of the system here. So what we'll do is slide a coin on the coin slot, and what it's going to do is break a light beam that's going from an infrared LED to a phototransistor, and what we're looking for is a 1 in 5 chance. So maybe you'll win on the first try, but you will win by the 5th try. And what happens is it activates a relay which will release the sword. And what is making this all work, we do have an Arduino Nano microcontroller that's been programmed to open up. And there are 2 modes of operation. We can do either a 1 out of 5 chance of winning, releasing the sword, or a 1 out of 100 chance of releasing the sword. Once a coin passes through and the sword is released, the whole system can be reset by pressing down on a switch. In addition to that, there is a toggle switch here which can toggle between 2 modes, which is the 1 in 5 chance of winning or the 1 out of 100 chance of winning. And finally, we do have an LCD display that kind of shows the current status, how many coins have passed through, and things like that. There's 3, 4, 5. Ready to lock it up?
Mm-hmm. Lock back in there. Not coming out. Now we just have to see if the 1 in 100 mode works. This just involved rocking the mechanism back and forth 100 times until the coin passes through enough times to be able to trigger a winner. Oh, well that was rather quickly. How many tries was that? 13.
Okay.
Awesome.
Watch your fingers.
All right. Yay! It works. For those that are experienced with electronics and want to know a little more, here is the technical map that looks like plain Greek to me. So now that I know that the electronics are all working properly, it's time to integrate the system into the decorative box I've designed. I took all of the electronic equipment and packed it neatly inside the box so that it wouldn't be bumped by the coins. I also drilled a couple of holes at the top of this repurposed plastic container so that I would have easy access to the switches. The electronics tucked away inside the container, I'm easily able to reset the system and toggle between the two different modes. I found some leftover chicken wire in a barn to be able to use as a base for the rock. I've got loads of this shredded paper that I used for another project, so I just loaded them into individual grocery bags. Once they were full, I tied them off on the top like little lumpy pillows. Tried as I might to keep the mess contained, it did not work out that way. There were about 50 in total. I started layering them up the sides of the system. I wanted this lumpy, organic looking feel for the rock itself. And yes, that is a big, huge mess. Then I started layering the newspaper up the sides to help keep the bags from getting ripped open during the process and contain the mess. Don't worry, I'm going to repurpose all of this. Okay, so here we've got a view of the whole thing. I would have done like a process video about how I did all this chicken wire and stuff, but anybody that's ever worked with chicken wire, I didn't think you wanted to spend 45 minutes watching me struggle with this, so I used what I had and then attempted to piece together some more. But this whole thing is covered with chicken wire and now is ready for plastic.
So I am finished with the complete inner workings of the stone. I wish I had a final shot of the framework for you, but the process is being hurried along. The Nebraska State Fair needs a finished photo of my project for their brochures, so the construction on the stone outside is already underway. Overall, aside from the little hiccups, I am super happy with how this project is progressing. I'd like to take this opportunity to thank everybody that's helped me out so far. I needed a lot of help with this part of the project, and Nathan, Stefan, and Scott were just so amazing at being there for me and helping me when I really needed it. Crystal and her husband Richard and their daughter Lily are over here every single weekend helping me with little things on this project too. They're here helping with every phase of the project and their ideas and just everything that they do. I can't thank them enough for all of the support that they've given me. But there's one person I want to thank more than anyone. Josh has been here behind the scenes giving me advice and welding the crucible, helping me test the system, jumping into dumpsters with me looking for plastic, and also being the voice of reason when I start to get overwhelmed. He's been my rock through every project I've ever done. Pun totally intended. And I couldn't do any of this without him. You can check out House of Chains' music. Chains? Music? Changes? Chains' music? You can check out House of Chains' music linked down below. Be sure to hit that subscribe button to see the next video and the last part of this video trilogy. But that's it for part 2, and part 3 is already underway, and I can't wait to share it with you all. See you in a couple of weeks.